A brilliant comet burst into view close to the sun, its luminosity surging dramatically in a single night, with the tail expanding to span more than the width of 5 full moons side by side. Shortly afterward, the sun fired off its most powerful solar flare in recent months, hurling a colossal plasma surge directly toward the region of space where Comet C/2025, dubbed Swan, is racing toward our planet, as the headline indicates. Come October 21st, Swan will approach its nearest point to Earth yet, coinciding almost precisely with the passage of yet another visitor from beyond our solar system. As incoming solar disturbances prepare to collide with the comet's enormous tail, the outcome remains a mystery. Could the heavens ignite in a spectacular display, or will it all fade quietly? The sequence of events is now in motion. So, what unfolds when solar fury encounters this celestial intruder? On September 12, 2025, Comet C/2025, now known simply as Swan, orbits the Sun at a mere half an astronomical unit away, nearer than Mars ever gets to our world. Initially, the readings appeared ordinary, a dim, gradual brightener at magnitude 7.4, with a tail extending just 2 degrees across the evening sky. Yet comets thrive on the unexpected. Barely 2 weeks after reaching perihelion, the illumination spikes sharply. On September 26th, hobbyists in Japan and Australia detect the initial indicators. An abrupt increase of nearly 1 full magnitude elevates Swan to visibility without aid for those in pristine dark sites. Within hours, online astronomy communities explode with real-time light measurements, verifying a rise to 5.7, stabilizing around 5.8 by September 28th. This surge goes beyond mere data fluctuation. Such explosions trace back to the core, a icy heart scarred by eons in the void, now pummeled by intense solar radiation. As Swan arcs away from its solar closest approach, hidden reservoirs of unstable materials beneath the surface hit critical thresholds. Vapors erupt outward, towing along particles and frost, expanding the hazy envelope and nourishing the tail. The impact hits fast. Brightness patterns stray from forecasts, and each new sighting offers insights into the subsurface dynamics. Heat-induced strain, gas releases, or even partial structural failures. All possibilities emerge. Certain watchers notice suggestions of stream-like formations close to the core, potentially signaling surface cracks or emerging outlets. Swan's actions stray from typical comet norms, captivating experts and a worldwide cadre of amateur stargazers alike. At present, the data speaks volumes. Swan has shifted into an altered state. Its central mechanisms laid bare, future developments impossible to foresee. Beyond peak brightness, the real intrigue lies in how this liberated power might reshape the comet's form and the expansive tail billowing in its wake. A tail now measuring over 2.5 degrees in the heavens, equivalent to 5 moons aligned tip to tip. For enthusiasts of the night sky, this vastness transforms the view. No longer a mere smudge amid the constellations, it becomes a feature traceable via basic binoculars, a prominent band that captures focus even from light-polluted areas. Such immensity exposes more of the comet's enigmas. Clusters of debris, evolving beams, and the subtle azure glow of the charged particle tail, all molded by the sun's breeze. The tail's design narrates an ongoing tale. The dust component, denser and more sluggish, hugs the orbital track, creating a wide, sun-glowing arc. In contrast, the charged tail, finer and more reactive, might twist, undulate, or detach entirely amid favorable solar influences. With Swan's tail now dominating a swath of sky broader than any urban horizon, modest scopes reveal details, flows, curves, and abrupt turns. For those monitoring from dusk to dusk, the evolutions stand out clearly. One night's vigil might uncover a fresh curve, a dimming stream, or a quick flare as new ejecta flows from the heart. The international comet enthusiasts are mobilizing swiftly. Volunteers spanning time zones are layering images, exchanging insights, and posting dynamic clips that capture tail shifts by the hour. Discussion boards flare with accounts of nuanced hue variations, cool cyan for charged particles, warm amber for grains, suggesting intricate compositions in play. Swan's low southern placement through much of September and October benefits viewers in Australia, South Africa, and Argentina. However, as it rises and the lunar phase dims, northern regions gain opportunities too. For holders of everyday binoculars, the coming weeks provide an up-close vantage on a dynamic demonstration of cosmic mechanics. The tale's extension implies more than visual thrill. It primes the scene for the sun's impending blast wave entering that same cosmic sector. Now the puzzle extends to not only the tale's potential elongation, but its response to the arriving solar gusts. At 0843 UTC on September 28th, the sun unleashes an M6. For flare, its fiercest in months. Throughout most of September, sunspot action stayed subdued, with X-ray levels from the GOES satellites remaining steady, indicating a pause in the ongoing solar cycle. Then, abruptly, the detectors surge. The flare's immense power, quantified in millions of kilowatts, illuminates the GOES 16 and GOES 18 displays in almost instantaneous fashion. Solar experts at the National Oceanic and Atmospheric Administration Space Weather Prediction Center scrambled to assess the event, cross-checking with Solar Dynamics Observatory. Imagery and coronagraph data from the Solar and Heliospheric Observatory. This is not just another solar hiccup. M-class flares are mid-tier on the scale, but an M6 is enough to catch the attention of satellite operators and space weather forecasters. The flare's origin, active region 4232, a complex sunspot group with a twisted magnetic field, places it in the same quadrant of the sun that Swan is now approaching. Within 30 minutes, coronagraphs confirmed the launch of a coronal mass ejection. The CME's initial speed, estimated between 800 and 1,000 kilometers per second, puts it among the faster eruptions of the year. Inside the operations rooms, alerts ripple out. Satellite teams double-check protocols for radiation spikes, but this CME is not Earth-directed. Instead, the focus shifts to what lies in its path. The timing, just 2 days after Swan's outburst, draws immediate notice. Duty officers flag the event for comet scientists, who begin modeling the possible intersection of the CME with Swan's expanding ion tail. For now, the numbers tell the story. An M6.44 flare at 0843 Coordinated Universal Time. A CME racing outward and a comet with a tail more than 2 degrees wide in the line of fire. The sun, quiet for weeks, has sent a powerful pulse into the same sector of space where Swan is putting on its own show. The intersection of these events is rare, and every instrument from GOES X-ray detectors to ground-based telescopes now has a reason to watch closely. Inside the NOAA Space Weather Prediction Center, the race began as soon as the flare peaked. Analysts pulled up real-time feeds from SHO's LASCO coronagraph and Stereo A's heliospheric images, combing through frames for the expanding arc of plasma. The CME launched just after 0845 UTC, fanned outward with an initial speed near 900 kilometers per second, fast enough to cross the average Earth-Sun distance in less than 2 days. Its angular width, measured at approximately 90 degrees, placed it among the broader ejections of the year. But the crucial detail was its aim. This time the blast missed Earth by a wide margin. Instead, model overlays showed the main lobes sweeping into the sector of space now occupied by Comet Swan. For the forecasting teams, the challenge was geometry. Solar ejections don't travel in perfect straight lines. They expand, twist, and sometimes fragment as they plow through the solar wind. To chart the CME's path, scientists stitched together coronagraph images, plotting the leading edge against the known positions of planets, spacecraft, and for the first time in years, a comet with a tail longer than 2 degrees. Swan's coordinates just inside Earth's orbit, slightly south of the ecliptic, put it near the predicted corridor, but the three-dimensional uncertainty remained. Without a direct Earth hit, in-cytoplasma data would be limited, leaving ground-based and orbital imaging as the best tools for tracking the encounter. Every major forecast center flagged the event for comet researchers. The question, would the CME's broad front actually intersect Swan's tail or sweep harmlessly past? The best estimates placed the CME's arrival in the comet's vicinity between 48 and 72 hours after launch, depending on the true trajectory and speed. Density projections suggested a moderate event, enough to disturb the ion tail, but unlikely to trigger any terrestrial effects. For Earth, the risk was minimal. For Swan, the incoming solar plasma set the stage for a possible display of tail kinks, disconnections, or rapid changes. Phenomena that could unfold on time scales of hours, visible to anyone watching the right patch of sky. The tools were ready. The data streams open. Now all eyes shifted to the comet corridor. Magnetic fields shaped the fate of every comet tail caught in the solar wind. When a coronal mass ejection like the one launched on September 28 sweeps across space, it drags with it a tangled web of magnetic field lines, each one carrying its own orientation. The ion tail of a comet is built from charged particles stripped from the nucleus and pushed away by the sun's constant outflow. These ions don't just drift. They cling to magnetic field lines, forming a kind of invisible tether stretching millions of kilometers behind the comet. But the real drama begins when those lines meet the boundary between the comet's tail and the incoming solar wind. If the magnetic field embedded in the coronal mass ejection points southward opposite to the typical direction near the comet, conditions are ripe for what physicists call magnetic reconnection. This is the cosmic equivalent of a circuit breaker snapping open. Field lines from the solar wind and the comet's tail collide, snap, and rapidly rejoin in new patterns, releasing energy and cutting loose whole sections of plasma. In practical terms, this means the comet's tail can break away in minutes. SE observers might spot a luminous piece breaking away and floating into the void as a fresh tail starts to emerge right away. The direction of the coronal mass ejection's magnetic field, particularly its BZ element, dictates how intense this phenomenon becomes. A southward BZ often acts as the key catalyst to detach the tail, whereas northward orientations tend to pass through with minimal disturbance. This sequence happens swiftly, occasionally detectable in mere hours, resulting in striking bends, abrupt fades in luminosity, or even a separate ion cloud traveling on its own. For researchers and simulators, it presents an uncommon opportunity to witness magnetic reconnection unfolding at a magnitude beyond any lab setup. With each bend and rupture etched vividly across the heavens in live action, time is of the essence right now. The phase for major shifts is underway, governed by straightforward principles. Monitor the tail closely, rely on your observations, and stay adaptable in your forecasts. The ion tail of Swan, stretching over 2.5 degrees, faces the unbridled impact of the solar wind. Should the CME's field lines cross the comet's trajectory, the ion tail might twist or break off in under 90 minutes, a dynamic that typically occurs unseen in remote space for other comets, yet here unfolds before amateur scopes. Spectral features could alter sharply, with hydrogen and oxygen emissions shifting by as much as 50 kilometers per second amid the plasma's response to the impact. Structural changes might occur faster than a film's pace, featuring a vivid strand detaching or a replacement tail sprouting after a severance. This represents astronomy in motion, and prime insights could arise from amateur observers equipped with just a lens and unobstructed views. Yet, prudence is vital. Not all fluctuations or abrupt dulling signal a solar outburst. The CME's trajectory alignment remains uncertain, and forecasts of head-on interactions are still speculative rather than confirmed. Specialists advocate for attentiveness over assurance. The ideal approach involves recording, analyzing, and sharing findings, compiling an international archive as the comet's narrative progresses. At present, transformation is the sole certainty. The subsequent irregularity might emerge in one snapshot, and observers worldwide are tuned in collectively. On October 21, 2025, the figures paint the picture. Swan will glide within 0.25 Australian dollars of our planet, roughly 39 million kilometers away, equivalent to about 100 lunar distances. For a comet, this equates to an intimate planetary pass. The setup isn't coincidental. Its path intersects the ecliptic at a gentle incline, navigating the unseen layer that serves as the solar system's primary pathway. Positioned slightly below the ecliptic, Swan sits in the heart of where solar wind and the heliospheric current sheet exert the strongest influence. That very day, the interstellar guest 3I/Atlas attains superior conjunction, positioned sunward opposite Earth as Swan hits perihelion. Though separated by vast distances, these two entities traversing a shared expanse provide a unique side-by-side look at local versus extrasolar behaviors. To orbital experts, this configuration stands out as a rare occurrence. The probability of such objects, one hailing from the outer solar reaches and the other from beyond, aligning near the ecliptic within days, is extraordinarily low. The schedule adds to the intrigue. October 21st coincides with a new moon, banishing moonlight interference and yielding the month's blackest nights. As Swan nears its closest, the parallax, subtle positional variances from various Earth vantage points, turns detectable via basic home setups. Position charts depict Swan ascending nightly, its tail carving through southern star patterns. The real-time Earth-comet divide narrows to a quarter of the Earth-Sun span, delivering the optimal viewing slot before Swan ventures back into the depths. For those eager to glimpse Swan over the upcoming evenings, precision and readiness are crucial. October 21st marks the peak moment. Minimal approach, new moon, and prime darkness. But the opportunity extends. Trailing just below the ecliptic, Swan ascends progressively through southern skies. From Buenos Aires to Perth, it emerges early and persists into dawn, its tail arcing westward over the skyline. In higher northern regions, visibility enhances through the month, with Swan cresting treetops post-midnight and elevating further each evening. Constellation maps locate Swan along the edge of Crux and Piscis Austrinus. Spot it easily by drawing from Fomalhaut to Mala, the area's luminous star. The tail's alignment suits direct contrasts with nearby stellar points. At 2.5 degrees, the comet's streamer matches the span from Altair to its close companions. Binoculars with a 7x50 view encircle the full tail effortlessly. Modest telescopes uncover finer points, though a sturdy tripod allows photographers to snag that comet trail in mere seconds of exposure. As Swan draws nearer, the parallax method kicks in. Positioned only 0.25 astronomical units distant, the comet's spot in the sky nudges subtly based on your vantage point. It's a shift you can detect with a bit of time, say, several hours, and sharp observation. Hobbyists around the world are teaming up, recording when it rises and sets, and exchanging image layers to monitor the tail's evening-by-evening shifts. The routine is straightforward. Mark the comet's location, draw or snap the tail, and keep an eye out for twists, abrupt glow-ups, or dimming. No matter if you're amid urban lights or out in the countryside's blackness, each viewer contributes a vital detail to the worldwide view. Now's your chance to get involved in the vigil. This unusual alignment creates a chance for a well-recorded brush with destiny. With Swan hitting its nearest point to our planet on October 21st, roughly 0.25 astronomical units off, experts are eyeing potential influences from the CME on the comet's charged tail. Such interactions are famed for sparking quick, eye-catching alterations. That said, the precise results of this sun-comet clash are still up in the air, and there's no confirmed tie between the latest solar burst and Swan's prior flare-up. But what's certain this October is that both backyard stargazers and pros get a special peek at comet antics and solar action unfolding live. Through the international monitoring effort, Swan's path offers a prime shot to follow these space mechanics in action, with major findings yet to emerge.